standard formulae, as they are antiderivative. So first we have to know the formulae, standard formula of derivative. After this, you can see the formula of integration. First, our very important formula in derivative of constant. What is the derivative of constant? It will be 0. Means there is some number that is plus minus, it will be 1, 1000, 1 lakh, whatever. The derivative of this constant number is always 0. The file opposite to this, what we have to do here, we have to take integration of this function is equal to this. That is, I will show. If first formula is integration, one second, I will show it by derivative with integration. Okay, so first derivative of constant is equal to 0. We know, all of you very familiar with this formula. Okay, now what we have to do, we have to take integration of this formula. As just seen the definition, antiderivative is integration. So what do we have to do, integration of, we have to take integration of this function. Okay, so I will take integration 0. Okay, this dx will be here, it is divided, so it will get multiply here, or it is, as this integration is with respect to x, so we have to take dx. Okay, is equal to this function. Integration of this will be this function, that is c. Okay, now I will show second formula as well. Now derivative of x with respect to x, which is equal to 1. We know this formula in derivative. Okay, so as derivative of this x with respect to x is 1, this is your derivative. Okay, I will write it by d. Okay, now integration, we have to take integration. So add integration of this one will be x. Okay, so I will show this by formula. Integration 1 dx means integration with respect to x, and answer will be x. Okay, but we have to write compulsory plus c for constant number. Okay, so we have to write plus c in every formula. Now third formula, derivative of x raised to n. Now what is the formula for this? N x raised to n minus 1. As we have seen in introduction, integration derivative makes small parts, therefore it will be decreased. But in integration, what we have to do, in integration we have to add that small part. Therefore the formula of this is increased power of x. As you can see here, power of x will be decreased, that is n minus 1. Here opposite same process, means what, we have to add plus 1, x raised to n plus 1 divided by n plus 1 plus c. Okay, so we have to add plus c everywhere. Now we'll see one example. If integration x square dx, what we have to do here, we have to add 1 in given power, that is x raised to 2 means 2 plus 1 divided by same number, that is 2 plus 1 plus c, means the answer is x cube divided by 3 plus c. Similarly, integration, if I will take x raised to 4 dx, then answer will be, we have to increase power by 1, that is x raised to 5 divide by the same number 5 plus c. Okay, so it is exactly opposite to derivative. Now we'll see the second formula. Next one is logarithmic function. If you remember, derivative of log x. What is the derivative of log x? All of you remember, 1 upon x, as we have seen already in first semester. If you don't, I will show it. Okay, so derivative of log x is 1 upon x. Then integration of this function will be log x. Okay, means formula for this we can write it as integration 1 upon x dx is equal to log x plus c, and we have to write this plus c everywhere. Now next one, exponential function. If you remember what is mean by exponential function, the function which contains e raised to x, a raised to x, or this type of functions, means raised to power x में होनी चाहिए. Okay, so e raised to x. So derivative of e raised to x is e raised to x plus c. Sorry. One second. Derivative of e raised to x is e raised to x. Okay, now we have to write integration. So integration e raised to x into dx is equal to e raised to x plus c. This is very simple formula, that derivative of e raised to x is e raised to x and integration is also e raised to x. Next, second exponential function, important exponential function is derivative of a raised to x. If you remember, a raised to x means a means any number, that 2, 3, 4, whatever, 2 raised to x, 3 raised to x, 4 raised to x. Okay, so derivative of this will be a raised to x log. Now there is some slight change in this formula. Okay, if now we know that derivative of this function will be this, so integration we have to write like this. The integration of this function will be this a raised to x, but we have to take integration of functions of x only. Okay, so this log a is constant, so what we have to do here, this log a is multiply over here, so we have to take this log a on this side. Okay, and this log a is multiplied, therefore it will be get divided on this side. Therefore we can write formula for a raised to x is exactly opposite than डेरिवेटिव. मीन्स डेरिवेटिव में आप लोग log a को मल्टीप्लाई करते हैं तो आपको यहाँ a raised to x log a को डिवाइड करना है, log a plus c, that we have to add plus c over here. Okay, so these are basic formulas for I will show that derivative of root x. Okay, so derivative of one second. First, we will see the examples of this a raised to x. One second. What we have to do here, integration, if we have to find 2 raised to x dx. Okay, so derivative of integration of 2 raised to x is 2 raised to x, only we have to divide log of that number, that is log 2 plus c. Similarly, if there is integration 5 raised to x dx, the answer will be 5 raised to x divided by log 5 plus c. So in this way we can apply this formula. Okay, now next one is One second. Next one is which formula? Root x. Okay, derivative of root x. So what is the formula for root x is 1 upon 2 root x. Okay, 1 upon 2 root x. One second. Now, formula for this, the derivative of this will be this, so integration of this will be this. Now just we have seen, we have to find derivative of functions of x only, so this 2 will be constant, so this 2 is get divided over here, so it will be get multiply or this side, so integration of 1 upon root x into dx is equal to 2 root x. 1 upon 2, 1 upon root x dx is equal to 2 root x, exactly opposite of this function. Okay, so in this way we see first one algebraic functions, that is constant x raised to n, root x. These are algebraic functions, so just seeing the formulas for algebraic functions. After that, integration formula for exponential function, or the e raised to x, a raised to x, like this. Okay, now we'll see formula for trigonometric function. Important, there are some important formulas for derivative or integration. One second. Next, now we'll see derivative of sin x. What is the derivative of sin x? It is cos x plus one second. Derivative of sin x is cos x. Opposite to that means integration of cos x will be sin x. Therefore, we'll write this is integration cos x dx is equal to sin x plus c. Similarly, next one. What is the derivative of cos x? As we have already know, derivative of cos x is minus sin x. Okay, here we have to take integration of positive functions of x only. Therefore, we have to take integration of sin x only. So, this minus will be here, minus cos x plus c. Okay. In this way, you can see over here, derivative of tan x is sec square x. So integration of sec square x is tan x plus c. Similarly, derivative of cot x plus c is equal to minus cosec square x. Then integration of this cosec square x is minus cot x plus c. Derivative of sec x plus c is sec x into tan x, while integration of sec x into tan x is sec x plus c. Cosec x, derivative of cosec x is minus cosec x into cot x, and integration of cosec x into cot x is minus cosec x plus c. Next, similarly, other ratios. Okay, next we'll show derivative of sin inverse x. Derivative of sin inverse x is equal to 1 upon root 1 minus x square. Derivative of sin inverse x is 1 upon root 1 minus x square. So, integration of this 1 upon root 1 minus x square into dx is equal to sin inverse x plus c. Sin inverse x plus c. Similarly, derivative of cos inverse x. We already know that derivative of cos inverse x is same. There is only minus sign extra, minus 1 upon root 1 minus x square So integration of this 1 upon root 1 minus x square into dx is equal to minus cos inverse x plus c. So now you can see here the LHS is same. Answer will be different, sin inverse or minus cos inverse. Therefore, if in given example we have integrate this root 1 upon root 1 minus x square dx, then you can write both the answers or any one of them, that is sin inverse x or minus cos inverse x. Similarly, derivative of tan inverse x is 1 upon 1 plus x square. Opposite to this, integration of 1 upon 1 plus x square dx is tan inverse x plus c. Derivative of cot inverse x plus c is equal to minus 1 upon 1 plus x square, while integration of this function 1 upon 1 plus x square is equal to minus cot inverse x plus c. Here you can see both integral, they are same but answer will be different. Therefore, you can write this or this. Okay. You can write tan inverse x as well as minus cot inverse x, but one from both of them. Okay. Similarly, derivative of sec inverse x is equal to 1 upon x into root x square minus 1. So integration of this function 1 upon x root x square minus 1 dx is equal to sec inverse x plus c. Similarly, derivative of cos inverse x. Okay, now you can see here the ratios which are start from c, that is cos, cosec, cosec into cot. The answer of this will be, you can see here, cosec and cosec into cot. The answer will be negative. Okay, then next one, here also the same thing. Next, some important integrations that are different from derivatives, that is integration of tan x dx is equal to log of sec x plus c. I will explain this by concept or definition of integration. So first, as derivative of log of sec x, derivative of log of sec x, we'll take the plus c. Plus c means constant. Okay, so this is composite function. Composite function means the function which contains two functions and one x. There is one common x. There are two functions log and sec, but there is one x only. Therefore, this is composite function. So, as we know, derivative of log x will be 1 upon x. Then derivative of log of sec x is 1 upon sec x. Okay, as derivative of log x is 1 upon x, derivative of log of sec x is 1 upon sec x into, if you remember, this will be chain rule, that functions are in chain form. So first we have to take derivative of log. Okay, so we'll take 1 upon sec into derivative of second function, and that second function is sec x. So into derivative of sec x plus c, and c is constant, so derivative of constant will be 0. So this will get erased or deleted. 1 upon sec x into derivative of sec x. What is the derivative of sec? Sec into tan, that is sec x into tan x. Okay, so you can see here this sec x is multiplied, this sec x is divided, so it will get cancelled. The answer will be tan x. As by the definition of integration, if derivative of log of sec x is tan x, then integration of tan x is log of sec x plus c. Okay, so integration of tan x dx is equal to log of sec x plus c. So in this way, we have to find another derivatives. So I will show here. Integration of cot x is equal to log of sin x plus c. If you want, I will show that one also. Integration of cot x. Okay, so first derivative of log of sin x plus c. Okay, as we have just seen, derivative of log of sin x. This is also composite function. By using chain rule, derivative of log of sin x is 1 upon sin x. One second. Derivative of log of sin x is 1 upon sin x. This is first function into derivative of second function, and second function over here is sin x plus c. C is constant and derivative of constant is 0. Okay, now this is 1 upon sin x as it is. What is the derivative of sin x? That is cos x. Okay, 1 into cos x is cos x. Cos x divided by sin x is cot x. This is trigonometric formula if you remember. Derivative of, cos x divided by sin x is cot x. Okay, so you can see here derivative of log of sin x is cot x. Opposite to that, integration of cot x dx will be this log of sin x. Log of sin x plus c. Okay, so in this way we can find integration of cot x. Next, integration of sec x into dx. We can take answer of this as log of sec x plus tan x plus c. Okay, wait, I will show this one also. You have to know how this formula will get formulated. Therefore, I am showing this all these formulas. Log of sec x plus tan x. Because क्या होता है, आपको फॉर्मूला तो पता होते हैं लेकिन कहाँ से आए ये नहीं पता होती है. सो फॉर दिस आई विल शो दैट 1 upon same thing like last formulas, 1 upon sec x plus tan x. Okay, this is derivative. This is also composite function. By using chain rule, we have to take derivative of log first, that is 1 upon sec x plus tan x into derivative of second function, and second function is sec x plus tan x in bracket sec x plus tan x plus c here, and derivative of c is 0 as this is constant. Is equal to 1 upon sec x plus tan x into, now we have to write the derivative of sec x, and just we have seen derivative of sec x is sec x into tan x plus derivative of tan x. Derivative of tan x is sec square x. Okay, sec square x. So now we can see here sec x into tan x plus sec square x. So here you can see what is common over here, sec x. Okay, so we'll take sec x common. One second. So I will take sec common. Sorry, sec x common in bracket. What will remain here? Tan x. Okay, and in second term, one sec is common and another sec is remaining, that is tan x plus sec x, divided by, you can see here sec x plus tan x. You can see this term will be same, tan plus sec or sec plus tan. Addition is there, therefore these terms are same. This both will get cancelled and answer will be sec x. Okay, so as integration of derivative of this sec x, log of sec x plus tan x is sec x. Opposite to that, integration of sec x dx is equal to, I will write here, is equal to log of sec x plus tan x plus c. Okay. Similarly, we can find last formula, that is integration of cosec x is equal to log of cosec x minus cot x. Think so. After these three formulae, you can find this formula also.